Okay, so I'm going to show you a few of the measurements that it's asking for in the physical pendulum part of the experiment. There's several quantities that all have to do with the meter stick, and they're a little bit hard to keep straight. They can be easily confusing, so you'll have to do your best to understand it and keep it all straight. So one of the things that we need to know is the center of mass of the stick, and we would expect that to be around 50 centimeters, right? So it's going to be thrown off a little bit by the fact that there's a hole drilled in the stick elsewhere at about the 80 centimeter mark. So it makes it not entirely symmetric. It'll still probably be pretty close to 50. But anyway, let me show you in another part of the lab. The way we find the center of mass of the stick is the same way we did in the Torx experiment, like this, where you just put it in this stand, and wherever you have to put it, then it's got equal mass on each side, and so it balances out. So that tells us the center of mass of the stick. You might find it kind of interesting too. I'll zero in. You'll see the hole right there drilled at about the 80 centimeter mark. Okay, same way on the stick that's hanging over there. This is obviously a different stick. I just put it here so I could show you. But anyway, back to the stick that we're going to use to actually get the measurements. Okay, so there's the center of mass of the stick. Okay, it'll be around 50. Now then the axis of rotation would actually be where this hole is and where the stick is hanging on this bolt here. Okay, so those are easy to confuse. Sometimes people confuse those. The axis of rotation is going to be this right here. Okay, so we're turning around there, around that axis. But then the center of mass of the stick is going to be around 50. Okay, so two different things. Don't confuse those. All right. Now there's another quantity that they call XP. Okay, X subscript P, and okay, what that's talking about is we want to know the photo gate. Remember from the other experiments, it's got a beam of light inside it, and when that's blocked, when that's tripped, it starts measuring. But where exactly on the stick does that beam of light exist? Okay, well that would be, there's a little light emitting diode in there. Let me kind of zoom in here. Okay, so I put a little piece of tape on there with an arrow, and you can see, you might see part of the light emitting diode there. So it's like around 2.4 centimeters or so, or 2.3. Okay, it actually doesn't look, when I'm looking at it in my phone here, it looks kind of bright, and I think that's just an illusion of getting some glare off the lights. Really, it doesn't look quite as much like that. But anyway, that's kind of nice. It makes it easier for you to see it. So right about there where that arrow is pointing, that's where the light is coming out of the photo gate, and it's around 2.3 or 2.4 centimeters on the stick. Okay. And then one more thing we need to know that has to do with the stick is how wide the stick is, and that's what they call little d in the data sheet. So we're going to take the caliper and just measure how wide the stick is. So just like this. Okay, so anyway, like about 24 point something millimeters. So anyway, just the size of the stick, just the size of the stick, across like that. Okay, so when we do our data run, then you're going to have the meter stick swinging through the gate. So the distance it'll travel will be the width of the stick, the little d distance, and then that distance divided by the time the computer gives you would give you the speed or the velocity of the stick as it passes through the photo gate. And we're catching it at exactly at the bottommost point of the arc that it swings through, and that would be the maximum velocity. Okay, so just a few of the measurements that you're going to need to do this. Okay.